Oh my gosh, but the first three are stuff you already know. So, easy peasy. We already know that the sine is y over r, opposite over hypotenuse. We already know that cosecant is the reciprocal of sine. Not new information, right? Same thing when we're looking at cosine, adjacent over hypotenuse, our x value over r, secant being the reciprocal of cosine. And tangent is the side opposite over the side adjacent, y over x. And cotangent is the reciprocal of tangent. Okay? So, what we're going to do is continue kind of on that idea of finding these trigonometric values, function values, outside of the coordinate grid, looking at opposite, adjacent, and hypotenuse. And so it's really important that we're aware of what angle we're referencing from, because as we change from angle to angle, these ratios are going to change as well. Okay? So we've got a right triangle given here. What side is my hypotenuse?
The longest side.
Which one's the longest side?
24.
25. Okay? If I didn't know the lengths of these sides, say I didn't know this one. Let's make that white. Oh, perfect. Say I didn't know this one. How would I know still that 25 is indeed the longest side?
Is it where the right triangle is?
It's at the right angle. Okay? So, we know it's opposite the right angle, so we know our hypotenuse has to be 25. Okay? Now, what side is opposite and which side adjacent is going to depend on what angle we're looking at. So, if I want to find my sine of A, I'm going to look at angle A. I'm going to reference angle A. Well, what side is opposite of angle A?
Angle?
What side is opposite angle A?
7.
7. What side is adjacent to angle A? 24. Okay? But when I look at angle B, what side is opposite of angle B? And what side is adjacent to angle B? Okay? So as we switch angles, opposite and adjacent also switch. So you need to make sure you're paying which one you're referencing. So what's sine of A going to be? Good. What's cosine going to be? And what's tangent going to be? And now with angle B, sine of B. Cosine of B. And tangent of B. Okay? Notice that sine of A is equivalent to cosine of B. Cosine of A is equivalent to sine of B. Tangent of A is the reciprocal of tangent of B. A couple things that we're going to kind of explore a little more. So sine of A is equal to cosine of B. Cosine of A is equal to sine of B. Okay? And tangent of A. Okay? What function is the reciprocal of tangent? Cotangent. And since tangent of A is the reciprocal of tangent of B, that means that tangent of A is equal to the cotangent of B. Okay? And this plays into some of our co-function identities that we're going to be looking at later. Okay? Something else I want to point out. Bright pink. Okay? If I knew the measure of angle B, what could I do to find the measure of angle A? From 180, right? Now, with a right triangle, we always have a 90-degree angle, right? So, if I take 180 and I subtract 90, I'm left with what? 90. So that means A and B together have to sum to 90 degrees. With a little bit of algebra, I can rewrite that and say that angle A is equal to 90 minus B, or I can say that angle B is equal to 90 minus A. Right? Because right triangles always have that 90. So A and B have to sum to 90 degrees. So this goes into our cofunction identities. All right? And we saw that relationship about how sine of A was equal to cosine of B. And because A and B have to be equivalent to 90 degrees, if I rewrite it and say that B is equal to 90 minus A, cosine of B has to be cosine of 90 minus A. I don't know why these are all over here. That's weird. There we go. Let's ignore that. Ignore that. Ignore that. Okay? So same thing with tangent. Since tangent and cotangent are reciprocals, we can take cotangent of B, which is 90 minus A, and we get tangent of A. Secant with cosecant, cosecant with secant, cosine with sine. All those reciprocals, okay, play into those cofunctions. So we can look and use that same concept here. We can evaluate cosine of 52, okay, has to equal sine of 90 minus 52. Well, what's 90 minus 52? So writing it in terms of its cofunction, cosine and sine are cofunctions. All we have to do is subtract the angle from 90, and that gives us our cofunction. Sine of 52 will be equivalent to sine of 38. Okay? What function is the cofunction for tangent? Cotangent. Funny how those are named, right? So, tangent of 71 will be equivalent to cotangent of 90 minus 71, which is what? Say again. 19. Okay, so tangent 91, its equivalent cofunction will be cotangent of 19. Now secant, what function is the cofunction to secant? Not cosecant. Cosecant. Okay, so what are we going to do to get the cofunction for secant of 24? 90 minus. What is 90 minus 24? Okay, so there's our cofunctions. All right, sine 38, cotangent of 19, cosecant of 66. Okay, cofunction identities. All right, now the rest of these, so the last like half of these will be kind of the really big part that you're going to be using a lot. Are special right triangles. I'm going to show you how to make the special right triangles so you don't have to memorize a bunch of random numbers, because these are very, very commonly used trig functions. Okay, so what we're going to do to make our 30, 60, 90 triangles, we're going to start with an equilateral triangle. What is an equilateral triangle? All sides are equal. If all sides are equal, all angles also must be equal. So we can make an equilateral triangle and say, okay, well, it's 60, 60, 60. And then I pick 2. We pick 2 because 2 is a nice, easy number, okay, to work out some stuff that we're going to do. We could pick any number and we'd still be able to simplify, but this makes the least amount of simplification. So we start with a equilateral triangle where all sides are 2 and then all angles are 60 degrees. And then what we do is we're going to take that triangle and we're going to cut it in half. Okay? So if we cut it in half, I have 2 halves here. What's the length of this side right here? What's the length of this side right here? What can I do to find the length of that side right there? So let's find that side. A squared plus b squared equals c squared. 1 equals 2 squared. So our side is the square root of 3. And the other triangle will be identical to that. Okay, just the other side. Now let's look at the angles. What's the measure of this angle right here? 60. Nothing changed about that one. When I cut it in half and I bisected this base, what's the measure of this angle here? 90 degrees. And then using our triangle sum, angle sum property, what's the measure of this top angle up here? 30. That's where we get our 30, 60, 90 triangle from. A 30, 60, 90 triangle with basically the most simplified bases that are side links that we can have, okay, for a lot of our trigonometric functions. Okay, so our 30, 60, 90 triangle, we've got 1, 2, and root 3. Okay, 1, 2, and root 3. As long as you can recreate it by bisecting an equilateral triangle, you can figure out all of these values. Okay, so you either need to memorize the triangle or memorize how to make it. All right, usually one kind of begets the other. Memorize the triangle or memorize how to make it. And then we can find the trigonometric function values for 60 degrees. 60 degrees is a very, very common angle measurement that we're going to see, or something at least very similar to it. Okay? So sine of 60 degrees. We're referencing the 60 degree angle. What's sine going to be?
30.
What's sine of 60 degrees going to be? 3 over 2, our opposite over our hypotenuse. What about cosine of 60 degrees? 1 over 2. And tangent of 60 degrees? 3 over 1. That is just root 3. Mix up the order here a little bit. Cotangent of 60 degrees is a reciprocal of which function? Cotangent, reciprocal of tangent. So what is cotangent going to be? Yeah, so we have 1 over root 3, which rationalizes to root 3 over 3. Secant is our reciprocal for which function? Cosine. So what's 2? 1/2. Reciprocal 1/2 is 2. And cosecant, that leaves us with reciprocal of sine. When we rationalize it, 2 root 3 over 3. Those 6 values, you're going to see a lot. Like a lot. Root 3 over 2, 1/2, root 3 over 3, 2 root 3 over 3, and 2. You're going to see a lot. So get used to it. But they come from this triangle. Okay? Before I go into that, real quick. If I wanted to, I could still use the same triangle to find all the trigonometric function values for what other angle? Okay? I'm not going to do 90. 90 is all going to be 1s or 0s or anything like that. But we can do it with 30. Okay? So our trig values for 60 and 30 are available from that triangle. The other special right triangle is our 45-45 right triangle. Okay? So we can construct this by just taking an isosceles triangle. Okay? What does isosceles mean? 2 of the same size. Okay? If we have 2 sides that are the same length, that means 2 of the angles are the same length. Well, if I have a 90-degree angle as one of the 3 sides and the other 2 angles are equal, that means the other 2 angles have to be 45 degrees. 45 degrees. Okay? Now to build this triangle, I'm going to pick a really, really easy number. A really, really easy side length. 1. Like 1. Okay? You can do 2 if you want. Just keep it consistent. You just got to simplify. But 1, we won't have to do any simplification. Well, we want to find our hypotenuse. Pythagorean theorem. Add it again. Pythagoras had his hand in a lot of trigonometry. I don't know why they were 1. Okay? What's 1 squared plus 1 squared? 2. What's the square root of 2? Just that, right? So our hypotenuse is root 2. So our 45, 45 right triangle is side lengths of 1, 1, and square root of 2. We can do the same thing by using this triangle to get our trigonometric function values for 45 degrees. So we know our side lengths are 1, 1, and root 2. Our non-right angles are 45. And it doesn't matter which one we reference because opposite and adjacent are the same. They're 1. So we're going to look at a 45-degree angle, and we're going to identify a sine. Sine of 45 degrees. Which rationalizes to what? Root 2 over 2. Cosine of 45 degrees. Also root 2 over 2. Because the opposite side and the adjacent side are the same. So cosine and sine are going to be equivalent. Tangent. 1. Cotangent. 1. Secant. Root 2. We take that reciprocal. Root 2. And then since sine and cosine are the same, secant and cosine can also have to be the same. Root 2. So those are our two special right triangles, and they comprise the most common trigonometric function values that you will be using. Okay? So you can either memorize two triangles, or you can memorize, what else could we memorize, Taryn? That you have a little bit of PTSD from. What's the other thing we could memorize? What was it? The circle. Well, memorize triangles. Because they form the basis for our most common trigonometric function values. So you're going to be seeing these numbers a lot. Okay? When you're working on your assignments, when you're studying or practicing, I don't want you relying on this chart to answer the questions. I want you to practice building those triangles, drawing those triangles, and referencing those. The key to your success. If you memorize those triangles, you will do pretty well. Okay? Because you're given all the answers on those two triangles for pretty much everything you're going to see. Okay? Questions, comments, concerns, queries, conundrums. All right.